What if a planet could outlive its star and end up orbiting the star's literal bones? Picture, for a moment, an odd little family portrait framed against the black, a grumpy white dwarf father. Compact and dense, wearing the groceries of a long-gone son in the wrinkles of his cooling atmosphere, a pulsar uncle. Whirling like a cosmic metronome, clicking beams of light across the neighborhood with the nervous energy of someone who will not sit still, a stubborn planet child. Scarred and strange, clinging to an orbit that most of us would call impossible. This is not a Hollywood alien set. These are real lives in the Milky Way, and they tell a story about survival, reinvention, and the universe's stubborn habit of keeping things weird. Let me take you room by room through this family home. The white dwarf is what remains when a medium-sized star like our sun runs out of fuel. It has no more nuclear fire, but it is incredibly dense and still glowing faintly as it cools. In some of these houses you find planets that were there before the star began its slow fade. They may have been large, gas-rich worlds once, but after their parent star swells and sheds its outer layers, those planets are left battered and changed. Some are stripped down to iron cores. Others are nudged into new orbits by the dying star's tantrum. The scene can be messy, but there is an odd tenderness to it. Imagine a planet that loses its atmosphere and then, like a child with a scraped knee, grows a new crust from the rubble left behind. It is a story of loss and adaptation. Then there is the pulsar side of the family. Pulsars are the fast, alarmingly punctual cousins. Dead stars collapsed into city-sized spheres of neutrons, spinning dozens or even hundreds of times per second. Their magnetic poles sweep beams through space like lighthouse signals. It feels wrong to talk about planets around such violent objects. But nature is rarely constrained by our sense of propriety. In a handful of cases, astronomers have found planets orbiting pulsars. Some of these worlds are likely survivors that somehow endured a supernova blast, while others may be second generation, formed from the debris left in the wake of that explosion. Either way, a planet orbiting a pulsar wears its history on its face. Imagine magnetic storms that would cook any atmosphere alive, or radiation so fierce that the temperature of the conversation in that neighborhood is permanently tense. What holds these family portraits together is not just the drama of death and rebirth but the improbable mechanics that let such systems exist. Tidal forces, orbital resonances, the Roche limit where gravity tears a body apart, and the chaotic ballet of multiple objects exchanging energy are the background rules of the house. A planet drifting too close to a white dwarf may be torn into a ring of debris that slowly rains down and pollutes the star's outer layers. That pollution is a sort of forensic fingerprint. When we analyze a white dwarf spectrum and see heavy elements we cannot explain, we realize that planetary material has fallen in. It is a quiet, forensic kind of evidence that planets were here, even if they are no longer whole. The humor in the family comes from personality clashes. The white dwarf is practical, old school, full of stories about the main sequence days when things were warm and steady. The pulsar is the show-off, always flashing and making a scene, attracting attention wherever it goes. The planets are the ones who keep showing up in the most inconvenient places. There is one who never learned to keep its distance and now exists as a stream of metal and rock slowly spiraling inward. A kind of cosmic goldfish circling the drain. There is another that, against all odds, hangs on in a measured orbit, boasting a coat of exotic ices with names we can barely pronounce and a magnetic field that acts like a stubborn umbrella against the worst of the radiation. The emotional high point of these stories usually comes when we realize how small our concept of permanence really is. These systems force us to confront the idea that planets are not always the stable, predictable backdrops we imagine. They can be survivors, refugees, or new children born of destruction. At the center of that realization is one of the universe's more poetic behaviors, recycling. Dead stars give up their matter. Explosions fling planets apart and sometimes back together. Gravity sculpts the debris into new orbits and new identities. If you think of a planetary system as a family, then death is not the end of the household, it is a messy remarriage. A shift in roles, a new set of responsibilities. There is also a quieter, stranger beauty to these systems. Around some white dwarfs we find dusty, flattened rings, the skeletal remains of shattered bodies. Look closer with the right tools and you can see the ghosts of entire worlds in the warm glow of infrared light. Around certain pulsars, regular timing variations hint at companions tugging gently on the neutron star. Their gravitational whispers translated into tiny delays in pulses. To translate those whispers into a narrative. To imagine what it means for a planet to orbit the corpse of a star. is to give human shape to the cold arithmetic of physics. It is where scientific observation meets empathy. You stop seeing a catalog entry and start seeing a story. Let us get personal for a moment. Imagine you are that planet. You have orbited a gentle main sequence sun for billions of years. A slow life of seasons and atmospheres, and perhaps the stubborn, slow work of geology. Suddenly the sun swells into a red giant and strips your upper layers. The sky burns. For a while, you are a refugee in your own system, flung into an eccentric orbit, battered by radiation and heat. If you survive, you arrive at a new normal that no life, if there was any, could have prepared for. Or perhaps you are younger. A planet born after the fireworks, pieced together from rubble and ash. Your first light is the glow of a compact star, not the comforting candle of a full sun. Which life is more tragic? Which is more hopeful? The answer depends on how you feel about second chances. The science can be precise and cold, but there is room for a little silliness. Picture a planet that calls its pulsar uncle every night, accusing him of stealing its moon, while the white dwarf father sighs and offers a crusty old joke about how the best moons are the ones you keep. The audience laughs because the scene is human, even though the players are made of iron and radiation. That humor, gentle and affectionate, keeps us engaged as the story moves toward its climax. The climax comes when we look directly at the question from the beginning and realize the stakes. Does the planet truly outlive the star? Or are we simply seeing the remnants of a different epoch rearranged by cosmic forces? The suspense builds because the answer is not a simple yes or no. As we near the end, there is an emotional beat where science and meaning meet. These strange systems are not just curiosities to be catalogued. They are reminders of resilience and reinvention. A planet stripped to its core becomes a monument to endurance. A newly formed world from stellar wreckage is a monument to creation from destruction. They teach us that stability is relative and that survival often looks like adaptation under pressure. There is also a cautionary whisper: everything familiar can change in unexpected ways. The normalcy we assume today might, in cosmic terms, be a temporary setting. That thought can be frightening, but it is also freeing. It asks us to value flexibility and to find beauty in unexpected arrangements. Now I will answer the question I posed at the start. Can a planet outlive its star and end up orbiting the star's bones? The short answer is yes, and also sometimes no. In some systems, planets survive the death of their parent star, altered but intact, pushed into new orbits and stripped of atmospheres yet still circling. In other cases, the planets we observe around stellar remnants are new creations, born from the debris of catastrophic events. Both paths are real and both speak to the universe's capacity for both destruction and renewal. That duality is what makes these systems so compelling. They are not failures, they are different chapters in a much longer story. If this little family portrait of the cosmos intrigued you, please do two quick things. First, tell me in the comments which member of this stellar family you would invite to dinner and why. Second, if you want more stories like this, the quiet, strange, and oddly human tales hiding in astrophysics, like the video and subscribe so I can bring you another cosmic family gathering next week. Thanks for listening, and remember to look up tonight not as a map of fixed constellations but as an ever-changing neighborhood where the weirdest houses often have the best stories.